that we've learned a good deal about derivatives and about the chain rule, we're ready to move on to implicit differentiation. With implicit differentiation, we're often going to be asked to find y prime. Y prime means the derivative with respect to x of y. Now notice that this y doesn't match what we're doing the derivative with respect to. If we're doing this with respect to x, and if this variable that we're thrown doesn't match that x, then we can't say what the derivative of y with respect to x is. We can use this format though. We can call it y prime. So it's important to note that the derivative of y with respect to x is the same as y prime. You could use these two notations interchangeably, dy over dx or y prime. If you recall, when we did the derivative with respect to x of x, remember that was, let me use the same color to really highlight this. That was the derivative of x with respect to x, right? The derivative with respect to x of x is the same as a derivative of x with respect to x. And what does that look like? It looks like a big happy 1, right? dx over dx, that's just 1. And that's why in the early start to derivatives, when we said that the derivative with respect to x of x, we just called it 1. But note that the derivative of y with respect to x, we can't call that something specific. We can just call it in general y prime or leave it dy dx. It's going to be important as we use implicit differentiation that you remember to use chains. The chain rule is going to come up again and again and again with every problem that we use implicit differentiation for. So heed this warning to remember your chains. Have you ever been caught in a snowstorm or on the top of a mountain? Maybe you went skiing in Colorado or somewhere with real skiing. And when I'm sorry if anyone's a Hidden Valley fan, it's better than nothing, I suppose. But if you want some real skiing, you go to Colorado, even Southern California, right? But when you're caught on top of that mountain, if you don't have chains, they sometimes won't let you drive down the mountain. Great way to miss class, right? You call your teacher and say, I was stuck, I couldn't get down the mountain. But it would be your own fault if that happened because you hadn't planned ahead, you hadn't remembered your chain. So keep that in mind. You're going to hear me say it again and again. Go ahead and count how many times I say, don't forget to chain. It'll come up again and again. Now, when we do the derivative of this equation, 4y squared plus 3 equals 2x cubed, with respect to x, it's like doing this. We're doing the derivative with respect to x of each of the terms in this equation. So it wouldn't hurt to write that each time. And do you notice how I wrote out these equations? I wrote them with that space so that I can go in and say the derivative with respect to x of each piece. Now I will say it's not absolutely required, but it's a great practice, at least starting out, to write these equations this way. So I am going to ask you, for the sake of this activity, to go ahead and write the equations out, writing that derivative with respect to x on each term. Let's go ahead and get started with a derivative. The derivative with respect to x of 4y squared, we're starting off on a little bit of a challenging one. It might look not so challenging, but when we're first starting out and we have to continually remember to chain, look at what's going to happen with this. It's like doing the derivative with respect to x of this 4 times something squared times the derivative with respect to x of that something. Now that something, that thing that we're inserting there, is of course this y. But you have to remember that the derivative with respect to x of y isn't just 1. So we have to chain it. So we'd multiply times that derivative. So this is what it would look like. Let me erase that and go back one more time to walk through that. When we do the derivative with respect to x of a term that has a y, we're going to do the derivative of the outside function. So in this case, the outside function is the 4 times y squared, the 4 times blop squared. And then what we chain with that is that blop, or in this case, the y. Now, what I've gotten here is only this first part. What I have highlighted here matches up to what's highlighted above. Let's look at this next piece. The 3, oh, that's so easy, right? Because the derivative with respect to anything of a constant is just a big fat 0. So that part was easy, right? That blue one. And then this last one isn't that difficult either. When we look at the derivative with respect to x of 2x, oh, I think that's supposed to be a cubed, right? The derivative with respect to x of 2x cubed. When I add that, it's going to be just 6x squared. 2 times 3 is 6, x squared. Now, you could think of it as chaining times the derivative with respect to x of this x. But what is the derivative with respect to x of x? Well, it's just 1. That's why we don't usually talk about it. Oh, do you see? I made a little error here. Let me correct that before we go much further. Did you see that? I should have carried down an equal sign here, of course. So let's go back and finish this up. The derivative with respect to 4 blob squared, we're going to do 4 times 2 is 8. Y to the 2 minus 1 is 1. But I don't really even have to write that 1, right? So the derivative of 4 blop squared is 4 times 2, 8 blop to the 1, or just this 8y. And then I can multiply that times this derivative with respect to x of y, which is dy over dx. I'm going to say plus 0, or just leave that off altogether, right? Equals 6x squared. Let me rewrite this slightly and call that dy dx. Let me call that y prime. And now all I've got to do is solve for y prime, because the direction said to find y prime. Here's where we go back to just basic algebra 1. And if I want to solve for y prime, I can divide both sides by 8y. So I have a y prime on the left, and y prime equals 6x squared over 8y. Notice that that can be simplified, so I'm going to write it as 3x squared over 4y. And there we have our first answer, and look, it even falls into place here in the answer box. Where was it? I found it earlier. 3x squared over 4y. Let's move quickly on to number 2. The derivative with respect to x of 5. That's just a constant, so we get a big fat 0. The derivative with respect to x of 2x squared. 2 times 2 is 4. And 4x to the 2 minus 1, so 1. Plus, and here's where I've got to watch the chain, because I'm going to say 2 times 3 makes me do it in two colors. 2 times 3 is 6. Y to the 1 less than 3 is y squared. But don't forget to chain, because now I'm going to multiply that times the derivative with respect to x of y, which I could rewrite y prime. The derivative with respect to x, the derivative with respect to x of y is just y prime. Now when I go to solve for y prime, I'm going to subtract 4x from both sides. So I have negative 4x equals 6y squared y prime. And to solve for y prime, I can divide both sides by 6y squared. So I get that y prime is negative 4x over 6y squared, but notice that I can reduce by 2, so 2x over 3y squared, and you'll find that answer in the answer box. Moving on to number 3, I'm going to just follow the same pattern. And you know what? I'd recommend, if you were following along step by step with this video, maybe try this next one on your own. Try this number 3 on your own. Pause the video and then come back and see if you're getting the same result. But that's the best way to do this. It's not a spectator sport, math. Math is an activity sport. You've got to jump in and practice yourself. I have each of the terms in this equation spread out, and I'm going to write this with the derivative with respect to x of each of them. The derivative with respect to x of 4 is 0 because that is a constant. The derivative with respect to x of 4x squared, that's just 4 times 2, 8. X to the 1 less than 2, so x to the 1. Now, if you want to, if it's easier for you to practice chaining every time, I could go back and say, then I'm going to do the derivative with respect to x of x, right? But that derivative with respect to x of x is just going to go away as a 1. But if it helps you to not forget to chain by doing that, then by all means feel free to write that each time. When I get to this derivative with respect to x of y cubed, the derivative with respect to x doesn't match up with this y, so I am going to have to chain. It's not optional at this point. So I'll do 4y cubed. That derivative is 12y squared. But then I have to go back and do times the derivative of y with respect to x. And I'm going to write that y prime. Do the same thing for the y squared. The derivative of a blop squared is 2 blop, right? But then I've got to go back and make sure I've done the derivative of that blop, in this case y, so I've got this y prime. When it comes to solving for y prime, I'm going to subtract 8x from both sides, because remember that the goal is to isolate those y primes. And one way to process through that, the way that you possibly were doing this in Algebra 1 was back when you first did algebra, maybe you highlighted or circled the thing you're solving for. So we're solving for the y prime. So we're going to isolate that out, right? And watch what happens if I factor out the y prime. What I get is 12y squared plus 2y. And so to solve for y prime, it looks like what I want to do is divide both sides by that 12y squared plus 2y. I'm going to write that like this. I'm going to put the y prime on the left. But watch what's going to happen here, because this does simplify. Maybe you've already caught and noticed and done the simplifying. But if you didn't, if you're looking at it thinking, well, what can I simplify? Be mindful of your simplifying. Make sure that when you divide out a 2, because 2 does go into 8 and into 12 and into 2, right? It goes into 8, 12, and 2. But we've got to be careful to certainly divide all 3 of those terms by 2. Not just, let's say, like the 8 and the 12. When I go to reduce, I've got to reduce all the way through. So what I'm actually doing is factoring out a 2 from the 12y squared and the 2y, and I can then divide out the 2. 2 goes into 8 4 times, 2 goes into 2 once, so I get that this is equivalent to negative 4x over 6y squared plus y. Now, often in class, a student will then say, but wait, can't we simplify 4 and 6? Well, you could simplify 4 and 6, but you can't leave the y out. So we're not going to divide any further. You can't just do 2 into 4 and 2 into 6 unless that 2 also goes into y. So we're actually going to leave it just like this. And notice that it does match up to the answer in the answer box. One more example here on the page, number 4. Let's go through this one a little bit differently. So I'm going to model this one more how I might just do it without showing every step, right? The derivative with respect to x of x is x. The derivative with respect to x of 5y squared, I'm going to be careful to change. So I've got 10y times the derivative of y. Notice how I had to chain and get that purple y prime because the y, what we're doing the derivative of, doesn't match what we're doing this with respect to. The dx and the y don't match up. So that's why I had to be mindful of doing that chain. And then we'll do the same thing here, 12y squared times the derivative of y equals, and how nice we get a constant, right? The derivative of 3 is 0. Now here's a mistake I've seen before. I've had tests grading where I'll see that the student will sometimes get to this next step and see this constant 1 and say, oh, the derivative of 1 is 0. But don't forget what we're doing. We're not doing the derivative now. Now what we're doing is going back and solving for our y prime, right? So what I'm going to do to solve for y prime is subtract 1 from both sides so that we have 10y y prime plus 12y squared y prime equals negative 1. In the same line, I'm going to go ahead and divide out my y prime. So we've got 10y plus 12y squared equals negative 1. So the I'm so sorry. I'm not sure why I wrote it like that. I think I was talking at the same time and wasn't being careful about what I was doing. When I factor out that y prime, I'm going to get a 10y plus 12y squared. And now, why did I do that all in one step? Let me go back here and just make sure that everyone knew what I was doing. I'm solving for this y prime. So I'm going to have to subtract 1 from both sides, and I'm going to have to divide out the y prime. So when I subtract 1 from both sides, that negative 1 comes over to the right side, and then I factor out a y prime and get 10y plus 12y squared. The last step is to divide both sides by 10y plus 12y squared. And there won't be anything that's going to simplify other than the best format, if we're being prim and proper, we're going to put our terms in descending order. So I'm going to put the y squared in front of the y. That might or might not be how an answer appears in this answer box, but to be precise, it would be a little bit better to write them in this format. That wraps up these first 4 examples. I do have 10 more examples that I'll work in future videos, but I hope that you're finding this one helpful.